Welcome to Earth Science Explorers. Today, we'll explore earthquakes and uncover their secrets. So, fasten your seatbelts as we embark on a seismic journey. Earthquakes occur when the Earth's crust violently moves. Let's explore our planet's structure to understand why. The Earth has layers, including the outer crust, a rigid shell divided into floating tectonic plates above the semi-fluid mantle. Tectonic plates slowly move due to heat and currents beneath them, but sometimes their edges get stuck. Pressure builds as plates push against each other, eventually leading to a sudden release of stored energy. And that's when an earthquake occurs. Have you ever wondered how thunderstorms occur? Let's take a closer look at the science behind this powerful and awe-inspiring weather phenomenon. Thunderstorms are caused by the buildup of electrical charges in the atmosphere. Warm air rises, forming thunderstorm clouds as water vapor condenses into droplets and ice crystals. Colliding water droplets and ice crystals create static electricity that discharges as lightning, producing thunder. Thunderstorms bring heavy rain, hail, and strong winds, sometimes causing damage and power outages. Thunderstorms may be powerful and sometimes dangerous, but they are also a reminder of the incredible energy and complexity of the natural world. In a world where nature unleashes its fury, brace yourself for the raw power of the tornado. A tornado is born from the clash of warm and cold air masses. In a supercell thunderstorm, warm, moist air rapidly rises, creating an unstable environment. As the updraft intensifies, a horizontal rotation forms, known as a mesocyclone. A rotating updraft can form a wall cloud, which may produce a funnel cloud. When the funnel cloud touches the ground, it becomes an official tornado, swirling with wind and debris. Ever wondered how tsunamis work? Let's explore these powerful natural disasters. Tsunamis, triggered by undersea events like earthquakes, volcanic eruptions, or landslides, occur when energy released uplifts the seafloor, displacing massive water and creating powerful waves that spread rapidly across the ocean. Tsunamis differ from regular ocean waves by having longer wavelengths and reaching heights of tens of meters near the shore. As they enter shallow water, their speed decreases while their height dramatically increases due to wave energy compression, resulting in a powerful wall of water crashing onto the land.